Okay, Assalamualaikum warahmatullahi wabarakatuh. We're going to discuss about LAN technology, especially for Ethernet technology. Ethernet is the technology that is most commonly used in wired local area networks or LAN, enabling devices to communicate with each other via protocol. The protocol is a set of rules or common network language. Let's see the simulation of using Ethernet technology in this connection. In this connection, there are three kinds of LAN. The first is LAN Solo, LAN Semarang, and also LAN Jogja. For each LAN, they are using LAN cable or fast Ethernet technology to connect DC to the switch. So for the Ethernet technology in this connection, especially for each LAN, are from LAN cable or UTP cable. The features or protocols or technology LAN with the name is Ethernet technology are the devices. The devices can be performed by PC, switch, and also router. And then the second is LAN cable. LAN cable are crossover or straight through. And one more is about addressing. For the addressing, there are IP address, gateway, subnet mask, MAC address. That's the protocol. So for the Ethernet technology can be performed by hardware. There are devices and also LAN cable. And one more, that is port Ethernet or LAN port. And for the connection method on LAN, they need to do some transferring data through the connection. They need Ethernet technology itself, and then physical address, MAC address, and then logical address. This is IP address, and also another protocol is windowing and ARP or address resolution protocol. So in this connection or on-LAN connection, the MAC address that is embedded in the NIC, the form is port Ethernet that is plugged by LAN cable, will do some work in this connection with the IP address from logical address. When the ASL firmware is set, the IP addresses for all of the PCs, so the IP address that we set before will be converted into physical address by the devices, and then after that the MAC address and IP address that is converted into physical address also will help the processing of transferring data through the connection. The MAC address will check the devices from the MAC address from the NIC, and the packet data will be sent by using IP address. That's the simple explanation of connection method on LAN.
First, let's separate the terms between Ethernet and IP. When most people think of Ethernet, we think in terms of a physical connection. You may have an Ethernet port on your computer in which you plug in a cable that then connects to a router or switch. This connection type is typically called a LAN connection. However, Ethernet is not a connection type, but instead an IEEE protocol. In our everyday use of the Internet, we typically just say that we are connected via Ethernet or wireless. It's much easier to say Ethernet than get into the weeds of the actual terms of connection protocols, stacks, layers, and the like. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. Now that we have said that Ethernet is a protocol versus a physical connection, let's get a little into the weeds of some of the terms. Most communications to our computers or devices travel over one or more networks via something called a packet. Since there's a multitude of devices that may want to send and/or receive data, there have to be some common rules for sending and receiving these packets. This is where the protocol comes in. One of the most commonly known protocols is the TCP/IP protocol. This protocol is widely used in Internet connections. The term TCP/IP relates to TCP, or Transmission Control Protocol, where the IP is Internet Protocol. There are other protocols, such as Open System Interconnection, or OSI, but for simplicity's sake, let's stick with TCP/IP for now. The TCP/IP is a layered protocol. Those layers are applications, TCP, IP, and network. Basic functions are explained, but there are many details in each layer. Each layer has a function that it performs, and when complete, is then passed to the next layer. In terms of the Internet, the transmitting computer will pass its data to the applications layer. This layer works with the application software to provide communications that may be required, such as HTTP, FTP, POP, DNS, IMAP, etc. That layer will add some data that will identify and direct the data, and then passes to the TCP layer. The TCP layer's job is to pack and unpack data and do some error checking. Onto the IP, or Internet Protocol layer, where some more identifiers are added, and then the data is transferred over the network layer, who then packages the data into Ethernet packets, or whatever other protocol is required, prior to transmission over to Internet Service Provided device. These data move up and down the stack, or layer, continuously, getting packed, unpacked, headers and info added, deleted, etc. So, through this TCP/IP protocol explanation, you learn that the transmission of the data results in an Ethernet packet. The device, applications layer, which can be Facebook, Google, a VFD, or a flow transmitter, will present its data, and layer by layer, the data is massaged and is then transmitted via an Ethernet packet to the network layer, which in turn is connected to your computer or PLC. Now that we have explained the Ethernet packet, we can get into the IP part of the Ethernet IP, or EIP description. IP in this case now correlates to industrial protocol versus the previous description of Internet protocol. Confused yet? The IP part of this protocol is simply the use of the Ethernet infrastructure in conjunction with the industrial protocol, which used Common Industrial Protocol, or CIP layers, that combine with TCP/IP, or User Datagram Protocol, or UDP layers, to create a protocol that can be used to support data exchange and control applications. We need to break down the TCP/IP, or UDP protocols slightly to give you an idea of which application may use which type. In the TCP/IP protocol, there's somewhat of a send-receive-acknowledge relationship. The packets go down the stack, received at the device connected to your network. A receipt confirmation goes back up the stack to the applications layer. This type of protocol may be used with a VFD where you command a speed and need to ensure that the VFD received the message. Conversely, with the UDP protocol, this is the continuous transmission, not requiring a receipt acknowledgement. This protocol would be used in something like Ethernet I/O on your PLC or a flow transmitter. These devices will constantly send the state of their data. If a packet wasn't received, it's not a deal breaker, as the next packet is right around the corner. CIP uses object-oriented design to present things like a device profile for a VFD. If you've ever used a CIP message instruction within your PLC device, you know that you research the type of data you desire, such as frequency, speed, or faults, and you add that assembly number to your CIP instruction. The data exchanged is a number of data registers that you in turn map to your tags for desired data. This EIP is compatible with many standard Ethernet switches used within the industrial automation arena, which makes it easy to implement. Combinations of data speeds of 10 or 100 megabits per second are easily handled with these off-the-shelf switches. In the simplest terms, Ethernet IP is Ethernet packets used with the industrial protocol of CIP, TCP/IP, and UDP layers to provide the required data to your controller.